Hello everyone, this is part 2 video on the past year NEET questions from hydrogen chapter. We'll start with a question that has come in 1992. At its melting point, ice is lighter than water. Actually, the density of ice will be lesser than the density of water at the melting point. The options given to us are option A, H2O molecules are more closely packed in the solid state. First we'll go through the options and then we'll see what is the correct answer. Option B, ice crystals have a hollow hexagonal arrangement of H2O molecules. Option C, on melting ice, the H2O molecules shrink in size. Option D, ice forms mostly heavy water on the first melting. So if you look at the reason why the density of water at the melting point is more than the density of the ice is because if you look at one H2O molecule as such, then the representation given over here in the B part is basically the open cage hexagonal arrangement structure for the ice. So we can see there will be a lot of these hollow spaces. That is the reason why ice in the solid state has lesser density. Now when the ice is melting, the open cage structure would be completely broken and the water molecules will come together due to the hydrogen bonding. So that is the reason why the density of the water at the melting point is more than density of ice. Now the correct answer will be option B, which is ice crystals have hollow hexagonal arrangement of water molecules, because of which there will be a lot of space inside the structure and density will be lesser. In case of water, why the density will be higher is because the water molecules will come together because of the hydrogen bonding. Now the other options, option A, H2O molecules are more closely packed in solid state. So if H2O molecules are more closely packed in solid state, then solid state must be having a higher density. So obviously this is not a correct answer. Option C, on melting ice, the H2O molecules shrink in size. Now it is not about the size of H2O molecules as such, it is about the intermolecular distances or intermolecular gaps. So this is also not correct. Option D, ice forms mostly heavy water on the first melting, which is not correct because heavy water is a completely different molecule. It is not about changing of hydrogen from one isotopic form to another isotopic form. So the correct answer for this is option B, which is ice crystals have hollow hexagonal arrangement of water molecules. Moving on to the next question. This is a question that has come in 1992. Water gas is produced by, water gas is a mixture of carbon monoxide and hydrogen gas. It's a very useful gas in terms of the industrial purposes. So the correct answer for this would be option A, because when steam is passed over red hot coke, we will be able to have a mixture of hydrogen gas and carbon monoxide, and that is what is the water gas. So the right option for this is option A, which is passing steam over the red hot coke. And in hydrogen chapter, this is one area where we have the chemical reactions, and we even have something called as water gas shift reaction. So you might want to go through that as well. And another area for reaction based questions is importantly the reactions of the hydrogen peroxide. Maybe we'll get some questions on that also, then we'll be able to take a look at it. So the water gas is prepared by passing steam over red hot coke. This is a question that has come in 1991. Hydrogen peroxide molecules are, so we have to decide whether they are monoatomic or diatomic and which type of ions they would form. So will they be forming monovalent ions or they will be forming a divalent ions? If you look at hydrogen peroxide as such, it will be able to dissociate to give H plus ions and HO2 minus ion. Basically, this is coming from H2O2. So we can see that hydrogen peroxide is diatomic and it will be able to give a monovalent hydroperoxide ion. The HO2 minus ion is called as hydroperoxide ion. So the correct answer for this is option B, which is diatomic and forms X minus type of ions because it is a monovalent ion. Moving on to the next question, this is the question that has come in 1990. Ionization of hydrogen atom would give rise to. So we have a lot of names given over here. Option A is hydride ion. Hydride ion is basically H minus ion. Hydronium ion is when proton is dissolved in water, it will be combining with adjacent water molecules to form H3O plus ion. They are called as hydronium ions. And hydroxyl ions are OH minus ions. So if a hydrogen atom, because the hydrogen atom will have only one proton inside the nucleus and one electron. So if the electron is lost, then the remaining thing will be just the proton. So the correct answer for this is option C, which is proton. This is a question that has come in 1989. Which of the following metal evolves hydrogen on reacting with cold dilute nitric acid, cold dilute HNO3? Now we know that with cold dilute acids only very strong metals will be able to react, and the answer will be magnesium. So magnesium can react with the cold dilute nitric acid to form magnesium nitrate and evolve hydrogen gas. I mean the other metals like iron, copper, aluminum, they will not be able to evolve hydrogen gas with cold dilute nitric acid. So the correct answer for this is option A, which is magnesium. Moving on to the next question, this is the question that is coming again in 1989. Which of the following is true structure of H2O2? Now we already discussed about the structure of H2O2. It is a non-planar structure. We talked about the change in the dihedral angle also in part 1 of this video. From gaseous state, the dihedral angle will change from 111.5 to 90.2 in the solid state. This is because of the hydrogen bonding that will be there in the solid state. But over here they are simply asking us which of them will represent the true structure. Now we can see option A, they are talking about a linear structure, which is incorrect. Option B is the non-linear structure, which is what the structure of hydrogen peroxide actually is. And anyway here the point that so we see the angle to be 90, it is not to be taken in the true sense. It is just to represent that it is a non-linear structure. And of course option C is not correct. We do not have an oxygen-oxygen double bond. Option D is also not correct because this is not the structure of H2O2. So the right answer is option B, which represents the non-linear structure of hydrogen peroxide, which is what it is. Moving on to the next question, this is a question that has come in 1988, and this is the question based on the reactions of hydrogen peroxide. The reaction of hydrogen peroxide with H2S is an example of. So we have to identify which type of reaction this is. Now if you look at the reaction of hydrogen peroxide with H2S, it will be able to release sulfur and form water. So what is happening over here is sulfur from the -2 oxidation state, because the oxidation state of sulfur in H2S will be -2. It is coming to 0. So there is an increase in the oxidation number, because oxidation number we have to consider along with the sign. So the oxidation number of sulfur is going up from -2 to 0. So any increase in oxidation number is basically called as oxidation, and decrease in oxidation number will be called as reduction. So this is an example of oxidation reaction, and that is about the hydrogen chapter. As we have already mentioned in the beginning of the part 1 video, this is probably not a high weightage chapter in terms of the number of questions you would get in the NEET, but in terms of scoring, if there are questions coming from this, they will be relatively straightforward and easy to answer kind of questions. All the best, and we'll see in the next chapter videos.